Okay, everyone. We are a group of three, and we are presenting a virtual assistant that's designed for Alzheimer patients called Memoraid. And for our goal, so nowadays it's extremely expensive for Alzheimer patients to get daily care, and the caretakers have to have a rich background regarding to their patients' information to help them. And using AI agent to solve that problem seems feasible, but the problems with the AI agents right now is that most of the AI agent doesn't have the ability to have long-term memory and to update their own knowledge bank. So to solve that problem, we developed a chatbot that can interactively address users' queries with factual information regarding to themselves and help maintain their daily routines through clear instructions and use those instructions to update their own knowledge bank. And the data we collected online from videos and research papers are mostly for diagnostic purpose and doesn't fit our requirement because we need daily conversations to test our system. So instead of using those data, we try to conclude some patterns from those data we collected. And using those patterns, we formed a virtual patient's profile and use those profile and those patterns we just discovered. We use GPT-4 to generate some QA examples. 35 questions for different levels of Alzheimer's disease. And here is the software architecture for our system. And as you can see, the user will first get a prompt to our system, and our intention node will analyze this prompt and gives the corresponding location of the information located in the RAG. The RAG will give this information to our natural language generation agent, and using the original user's prompt and this information that it retrieved, it will generate a human readable response, which will then be validated by our validation board. To develop this chatbot, we use two tools called ComfyUI and an extension of ComfyUI called LLM Party. It basically is a visualization tool that makes us easier to see the output of each node. And this is what it looks in ComfyUI. It's basically the system structure that I earlier just demonstrated. We also developed a GUI right here. And for our system, we developed two versions of agent composition. The version 1 is mostly consists of local language model that running on our own computer because we want to save budget. And the version 2 is surely consists of GPT-4 API. And as a result, the version 2 outperformed the version 1.
So we evaluated our system based on the test QA dataset, and the performance is measured based on the answering quality. We use a weighted score of human judge and BERT. The human judge is a Boolean indicator where we manually check if the generated solution answer actually resolved the question. And we take the precision metric from BERT score, which measures the proportion of semantic alignment between the hypothesis solution and the reference solution. So this is on a scale of 0 to 1, the higher the better. We use ChatGPT 4.0 as our baseline. Without using a RAG, we provide out the user profile as context and at the beginning of each conversation. Here's table 1 show our results. Our system has a 9% performance gap to our baseline model in the weighted score. And according to the human judge score, around averagely 94% of the questions has been answered correctly by our system. So this makes sense to us as the test user profile is a bit short. So it fits very well into the baseline model's context window. So the baseline model just makes decision with more information. And we investigated into the failed cases from our system, and we identified two main causes. First, our RAG system could retrieve the incorrect information. And second, our multi-agent board considers not just correctness, but also the softness and the tone. So it may reject some of the solutions that are semantically correct, but like for the good of the user. So our model, like compared to the baseline, saves around 70% of the tokens on average. And our model can propose updates to the care provider, which kind of reduce the burden on care providers. And our modular design makes it easy for customization and modification. So here are some example QAs. On the left, you can see the user's input is even like very challenging for us to understand. but our system gets it. And you can see typically the user's input is highly disorganized and grammatically incorrect. But the large language model, our system can interpret it and provide accurate information. This also highlights the potential of large language model in this domain. And this is an example of our reminder system. We're going to provide instruction to help user maintain a predefined daily schedule. So the user can also access external knowledge from our agent. And overall, our work achieved comparable performance on this task. And our system is like more affordable, scalable, and versatile. And for the lessons, in future talks, we would avoid using any high-level programming interfaces, as its simplicity in its implementation adds too much complexity in extending it. And effective communication is very important, and don't start too many tasks parallel, keeping them manageable. Thank you for your attention, and we welcome any questions and suggestions.